Do you ever stop and think about how you actually see? I don't just mean with your eyes, but the real physics of it. It turns out everything you see, from sunbeams slicing through the trees to your own face in the mirror, it's all run by a surprisingly simple set of rules. Today, we're going to break them down.
So let's just dive right into that big question. What are the rules that control the light hitting your screen right now and bouncing into your eyes? Well, they're the exact same rules that make a shadow on the ground or a rainbow in the sky. Let's get into it.
All right, to get started, just look at this picture of a forest. We've all seen this, right? These incredible sunbeams that look like solid beams of light cutting through the dust and air. It really feels like we can see the exact path light is taking. But is that what's really going on? Is it that simple?
Okay, let's figure out our first rule. We're going to walk through a really simple experiment, one that's designed to show us light's most basic, most fundamental behavior. And getting this one down is the key to understanding, well, everything else.
Here's the setup, and it's just brilliantly simple. All you'd need is 3 pieces of cardboard, each with a little hole punched in the middle, and a light source like a flashlight. We're going to use this to figure out exactly how light gets from point A to point B.
Okay, test number 1. You can see it right here in the diagram. First, all 3 of those little holes are lined up in a perfect straight line. Now, if we shine the flashlight through, do you think the light's going to hit the wall on the other side? It seems pretty obvious, right? But proving it is the crucial first step.
And now for part 2. We're going to make just one tiny change. We're just going to nudge that middle card over, so the holes aren't in a straight line anymore. The path is now blocked. So what happens? Does the light, bend or curve or find some other way to get through, or is it just stopped cold?
And the result gives us our first most important rule. The light doesn't go around. It only travels in a straight line. Now, the super scientific name for this is rectilinear propagation, which, let's be honest, is just a very fancy way of saying light travels straight. That's it. Rule number 1, locked in.
Okay, so if light only travels in straight lines, what happens when something gets in its way? This leads us straight to something we see, every single day, a shadow.
This page shows us exactly how that works. Check out the setup here. You've got a light source aimed at an object. In this case, it looks like a little cutout of a rooster, and because that rooster is opaque, which just means light can't pass through it, it physically blocks that straight path of the light. And this leads us to a really simple, logical conclusion. When that straight line of light gets blocked by something opaque, the light just can't get to the other side. And that area of darkness it leaves behind, that's what we call a shadow.
And here's the key idea. A shadow isn't actually a thing. It's the absence of a thing. It's just a patch of space where the light couldn't get to because its straight-line journey got interrupted. Every shadow you've ever seen is just a lightless spot in the world.
Okay, so light travels straight, and we know it can be blocked, but that's not the whole story, not by a long shot. Sometimes, when light hits an object, it does something really fascinating. It can take a detour. It can either bounce off or bend right through.
So let's look at 2 different situations here. At the top, you see light hitting a mirror. It doesn't go through, it bounces right off. Simple enough. But look below that. You see light hitting a glass of water. It goes into the water, but its path seems to bend. It's the same light source, but 2 completely different behaviors. What's going on?
Well, these 2 behaviors have their own names. When light bounces off a shiny surface like that mirror, we call it reflection. But when light passes through a new material and changes direction, like it does with water, we call that refraction.
And refraction is the reason for some of the coolest everyday illusions. Look at this chopstick in a glass of water. It looks bent, right? Maybe even broken, right there at the surface. That's not the chopstick. That's the light from the bottom part of the chopstick bending as it travels from the water into the air on its way to your eyes. It's a magic trick, performed by physics.
So, let's put it all together. What have we figured out? We basically discovered 3 simple rules that explain almost everything about how we see the world. Number 1, light travels in ruthlessly straight lines. Number 2, if you block that light with something solid, you make a shadow. And number 3, when light hits a new surface, it can either bounce, that's reflection, or it can pass through and bend, that's refraction. And when you really think about it,
From sunbeams to shadows, from your reflection in a mirror to that broken chopstick in a glass, it all boils down to those 3 simple rules. It really makes you wonder, if these basic principles can create so much everyday magic, what else is going on around you that's just physics, waiting to be seen in a whole new light?